Aye, aye, Captain. 5.3, Solving Polynomial Equations, Part 2. Part 1 was just factoring polynomial expressions. So now we're going to solve some equations. And the only difference is we're going to put an equal sign in the problem. All right, here is the fundamental theorem of algebra. For any polynomial, f of x is equal to a to the n power plus dot 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 just means that's just a generic way to write a polynomial. There are n number of zeros. So basically what the theorem says is when you look at an equation and you look at the x variable and then what its exponent is, if that exponent was a 2, like x squared, you would have 2 answers in your problem. If it was x to the 3rd power, you would have 3 answers in your problem. And so that's what the fundamental theorem of algebra says. If it was x to the 5th power, you would have 5 answers, or zeros is how they say it. So remember in our previous quiz, the zeros is the same thing as the answers, is the same thing as the solutions. So that's what it is. All right, so here's our first example. Solve by factoring. Okay, we have x to the 3rd power minus 15x squared plus 54x. Notice the fundamental theorem of algebra says that we are going to have 3 answers. Okay, so let's go ahead and find all 3 answers. The first thing I'm going to do is factor out an x. I'm going to pull out an x. Oh, the font is a little bit smaller. So when I pull out an x, I'm left with an x squared minus 15x plus 54 equals 0. So at this point, you can factor it again to get x times the quantity of x minus 9 times the quantity of x minus 6 is equal to 0. And at this point, you're going to use the zero product property to solve the equation. So you basically set each parentheses equal to 0. There's 2 sets of parentheses, and there's also that x in the very front. Never forget about the x in the front. So the x in the front, when you set it equal to 0, it's equal to 0. The second parenthesis, the parentheses that's x minus 9, set that equal to 0. And then the parentheses with the x minus 6, you set that equal to 0. And then you just solve, and that's a very basic. And there are your 3 answers. X equals 0, x equals 9, and x equals 6. Okay, let's do another one. That one came out a little bit slower, but notice that this equation is written kind of out of order and not in standard form. So the first thing you want to do is put it in standard form. Bring that 6x to the 3rd to the other side. Subtract it to the other side. And so you have this. Now we have an x to the 4th power, a quartic, if you remember your vocabulary word, which means we're going to have 4 answers. So let's see if we can find all 4 answers. All right, let's see. What can you factor out? What can we pull out to the front? I think you can pull out a 3 because they all have factors of 3 in them. And then you can pull out an x squared because they all have x squares in them. So when you do that, this is what we have. And then you're going to try to factor this part. But if you try to, I don't think you can. You can't do x plus 2, x minus 2, that doesn't work. So it actually doesn't factor. No matter how many times you would try to factor it, it won't factor out nicely. All right? So kind of like this, like there's nothing you can put in those blanks to make this work. You can put in a 2 and a 2, and that makes a 4, but then it doesn't add up to a -2, that middle term. You can put a 4 and a 1, that doesn't work either. So factoring doesn't work. But fortunately, in the quadratic chapter, you guys learned 4 different methods to solve a quadratic. To make it easy, I'm going to make you guys do the same method every time. So this is the answer for this part. The x equals the x squared right here. When you set that equal to 0, you just get x equals 0, and you get it twice. That's loud. Yeah, so you get it twice. So you can write x equals 0 twice, or you can just say x equals 0 with multiplicity of 2. We've learned about multiplicity as well. But then we need the other 2 answers. Remember, this one has 4 answers that we have to solve for. And so we have to take care of the other parentheses. Yep, you're going to have to use the quadratic formula to get the other 2 answers. And then you're going to use, oops, that's too much. Undo that. Erase. Yeah, you're going to have to use these numbers right here in the quadratic formula. There it is. I plugged it in. The A is 1, the B is -2, and the C is 4. Plugging it all in, simplifying it, subtract 4 minus 16, and you get -12. And remember, when we have a negative in the square root, we used to say no solution. But now we know what a negative underneath the square root turns into. An imaginary number. So then we can do 2 plus or minus 2i square root of 3. If you have trouble coming up with this, simplifying the -12, you have to go back a couple of chapters to figure out how to simplify square root of 12. But that's, you just basically do the factor tree. All right, and then at this point, if you can, all 3 of these numbers, if they can all reduce, go ahead and reduce all of them at the same time. And there's our final answer, 1 plus or minus 1i square root of 3 all over 1. All right, so that was a lot more complicated than initially thinking, but it's pretty doable. It's everything you already know how to do. It's just recalling all of that information and trying to do everything we've learned so far. All right. Let's factor by grouping. Notice there's 4 terms. We've done factoring by grouping before, and then sometimes it's pretty convenient when there's 4 terms. Something magical happens when you factor by grouping. You just group the first 2 terms together, and you group the second 2 terms together. So you kind of treat them as separate problems. So looking at the first term alone, the first group alone, what can you pull out? What can you factor out? An x squared. Oh, I did both. So there's the x squared. And then if you look at the second group and think, what can you pull out? You can pull out a 4. And there's our 4. And then do you see the magical thing that happens? They both have x minus 3's in them. All right, so when you did that, they end up with both having that x minus 3. Let me clean that up so it looks a little bit nicer. So you give the x minus 3 its own parentheses, and then the other set of parentheses you give the leftovers, basically the x squared plus 4. Okay, and so that's how you factor by grouping. Group the 2 together and then do it separately. It magically will share something, and then you just put the rest in parentheses. All right, and now that we've successfully factored, we can use the zero product property to set each parentheses equals to 0. Oh, just kidding. It turns out that you can factor the x squared plus 4 using imaginary numbers. All right, so yes, we learned how to factor perfect squares in the last section. So if you remember x to the second power, and then 4 are perfect squares, and that's how you would factor them. One with an x plus 2i and one with an x minus 2i. Remember, we use imaginary numbers because it was a plus. We don't need to use imaginary numbers when it was a minus. All right, so now that we have all of them in parentheses, we can set them all equal to 0. And there's our final answer, x equals 3, x equals negative 2i, and x equals positive 2i. Here is another example. Again, it's 4 terms, and so hopefully when I group the first 2 and I group the second 2, it works out nicely. And it does. With the first group, I was able to pull out an x squared, and then I'm left with an x minus 2. And then with the second group, I was able to pull out a negative 5. When I pull out a negative 5, I also have an x minus 2. So that works out nicely. And so the x minus 2 gets its own parentheses, and then the ones that aren't in parentheses, they get their own parentheses. All right, and there's a bug. There's a bug. Notice this. When you try to factor it again, it is not perfect. X squared minus 5 isn't perfect like the last example. The last one you had a 4, and a 4 was a perfect number, but a 5 is not a perfect number. So there's our first answer. We set the x minus 2 equal to 0, and we get 2. But then here's our second one, and how do we solve for it? Just go ahead and add 5 to both sides, kind of like a regular equation, and then square root both sides. And of course, if you remember, when you square root both sides, you have to put plus or minus, and of course the answer is cut off. But the final answer is x is equal to plus or minus square root of 5 with that 2. All right, so that gives us our 3 answers. 1, and then this is the second and the third answer. All right, let's move on. This says tricky. Let's see why it's tricky. How do we factor this? What can we pull out? I think the only thing we can pull out is a 5. So I pulled out a 5, and then I have a w to the 4th minus 16. All right. So from here, we're supposed to come up with 4 answers. So let's see if we can. The w to the 4th minus 16 can be factored. There it is. W squared minus 4 and w squared plus 4. They were perfect squares, the difference of perfect squares. And it looks like these also can be factored out because they're also the sum and difference of perfect squares. So that's how you factor them out. The w squared minus 4 turns into the w minus 2w plus 2. And then the w squared plus 4 were these two. They're the imaginary ones, because remember, the plus has imaginary ones, the minus does not. And then from there, we set all of those parentheses equal to 0, and we get our final answer. W equals 2, W equals negative 2, W equals 2i, and W equals negative 2i. All right. Ooh, let's go ahead and try to recognize perfect cubics. So equations with x to the 3rd power in there, but these are perfect. Let's see. So there's our first equation. Now, if you tried to solve this equation using pre-algebra or algebra 1, it would be very easy. And here's what you would do. You would, in algebra 1, you would first go ahead and divide that 5 from both sides. So when you divide both sides by 5, you get x to the 3rd equals 1,000. And then you have to use a little bit of brain power and think, oh, what times what times what gives you 1,000? And most of you guys can figure that out. And the answer is x equals 10. That's pretty simple. Unfortunately, according to the fundamental theorem of algebra, we actually need 3 answers. 3 answers. And so far we only have the 1. And if you guys are thinking, oh, what about negative 10? Negative 10 doesn't work because negative 10 times negative 10 times negative 10, that gives you negative 1,000. So that's no good either. So how do we get the 3 answers? By what we've been doing, factoring. So let's try to factor. All right, so instead of solving it like we would in Algebra 1, we're going to actually bring the 5,000 to the other side and set it equal to 0. Okay, once we set it equal to 0, what can we pull out? We can pull out a 5. And then, hopefully, you recognize that x to the third minus 1,000 is a perfect cube, where the x cube is a perfect cube and the 1,000 is a perfect cube. Then we were given formulas for perfect cubes, and so you can pull out last time's notes to look at the formulas. And so let's go ahead and use those formulas to factor that. And there it is. This 5 just stays in the front, but this is how you factor perfect cubes. We just did that in the last section. And then, so now we actually get that first answer. If we set each parentheses equal to 0, we get that 10, which 5 minutes ago we were already able to get that 10. But if you can see, this part will give us the other 2 answers we were looking for. Using what again? The quadratic formula. There it is, x squared plus 10x plus 100. Throw it in the quadratic formula. Simplify it a little bit. Simplify it a little bit more. Notice there's a negative 300 in the square root, which probably means we're going to have imaginary answers. Simplify that. And there is our imaginary I that we were expecting. And again, you got the 10, and the 2. If they all reduce, go ahead and reduce all of them. And there's our final answer. X equals negative 5 plus or minus 5i radical 3. So that, along with this 10, gives us our 3 answers. How fun! Let's just do another one of those again to make sure we got this concept. Here it is. 27 is a perfect cube. X is a perfect cube. And 1 is a perfect cube. So throw that in the perfect cubes formula. We get this. The first answer is x equals 1/3. If you do algebra 1 on that, you'll get 1/3. The other 2 answers comes from the quadratic formula. Throw those in there. Simplify a little bit. You get one of those. Again, we have a negative square root in the square roots, and so as a determinant, and so you're going to have an imaginary answer. There it is. I simplified it a little bit more, and then I'm going to reduce all the answers: the 3, and the 18. And there we have our final answer. I know I went through that pretty quickly, but it was the same steps as the question before. All right, what else do we have up in here? Tricky factoring. Ooh, I don't know what that means. All right, so we have x to the 4th minus 5x squared plus 4. How can we factor this? Does x squared minus 2x squared plus 2 work? No, I don't think that factors perfectly, because when you check your answers, it won't. If you FOIL this, it won't give you the right answer, so that doesn't work. You can try a -2 and a -2, and that doesn't work either. So this is a little bit tricky, but I think this does work. X squared minus 4 and x squared minus 1. All right, so that would work pretty nicely. Notice that those are now perfect squares, so they all factor again. The x squared minus 4 factors to this, and then the x squared minus 1 factors to this. And that's actually all the factoring we can do, and it turns out that we have 4 answers. X equals 2, -2, 1, and -1. This crow outside is going off crazy. All right, one last example for this section.